All right, let's jump right in. We're about to explore a cosmic mystery that involves, well, everything. Not just our planet, not just our solar system, but our entire home galaxy. This is the story of a journey that every single one of us is on, whether we realize it or not. So you have to start with this one fundamental question. Because it turns out, the universe is anything but static. We aren't just sitting still. Our galaxy, the Milky Way, is on the move in a big way, and it's being pulled toward something enormous. And when I say on the move, I mean we are seriously booking it. Our galaxy is hurtling through space at a speed that's almost impossible to wrap your head around. 2.2 million kilometers per hour. That's over 600 kilometers every single second. But really, the big question isn't just how fast we're going, but why? What's pulling the leash?
Now here's where it gets truly mind-bending. It's not just our galaxy. We are part of this massive cosmic current. The best way to picture it is like a giant invisible river flowing through space, and our galaxy is just one tiny boat being carried along. And it's a crowded river, for sure. We, along with about 100,000 other galaxies in our neck of the woods, are all being drawn in the exact same general direction. All of us are heading toward a single, still mysterious destination. As you might expect, scientists have a perfectly epic name for this cosmic focal point. This thing with a gravitational pull so immense it can tug on tens of thousands of galaxies at once. They call it the Great Attractor. Okay, so if we know this colossal object is out there yanking on our entire galaxy, why can't we just point our most powerful telescopes at it and see what it is? Well, the answer is frustratingly close to home.
And this is where the mystery really deepens. The very thing that's blocking our view is our own Milky Way galaxy. We're literally trying to look through the brightest, densest, most cluttered part of our own cosmic home to see something far away.
Astronomers have a name for this region of the sky. They call it the zone of avoidance. It's not some physical barrier, but it acts like a cosmic blind spot. It's created by the sheer amount of stars, glowing gas, and thick interstellar dust packed into the plane of our galaxy. All that stuff just scatters and absorbs the light from anything lying behind it. Here's a good way to think about it. Imagine you're trying to see a single candle flame on a distant shore, but you have to look for it directly through a giant, blazing bonfire. That's our challenge. The cluttered core of our galaxy is that bonfire, hiding one of the universe's greatest secrets in its glare.
So if we can't see it, how in the world do we even know for sure that it's there? Well, this is the really cool part. It took some of the most clever cosmic detective work you can imagine. Since they couldn't see the Great Attractor directly, they had to look for its influence. They became detectives, searching for its gravitational footprints all over the cosmos. They mapped the invisible by carefully measuring its effect on all the visible things we can see.
And the way they did it was just brilliant. It was basically a three-step process. First, they used the cosmic microwave background. That's the faint afterglow of the Big Bang as a perfect stationary backdrop for the entire universe. Then, against that backdrop, they measured the movement of thousands of galaxies. And they noticed they weren't moving randomly. They were all streaming towards one common point. And that point, that center of gravity, is the Great Attractor.
All that amazing detective work proved that the Great Attractor exists. But it left us with the ultimate million-dollar question. What is it? What could possibly have enough gravitational muscle to pull on 100,000 galaxies at once? Well, right now, there are two leading theories. So let's look at the prime suspects. Theory number one is, in a way, the simpler explanation. It's a colossal pileup of normal galaxies, a supercluster, hiding behind all that galactic fog. The Norma cluster is a big part of this idea. But then there's theory number two, which is way more exotic. It suggests the pull is coming from a gigantic, invisible clump of dark matter, that mysterious stuff that we know makes up most of the mass in the universe, but that we can't see at all.
Whatever the Great Attractor turns out to be, we now know it serves as the gravitational heart of our entire local cosmic neighborhood. This immense structure, which holds our Milky Way and all those other 100,000 galaxies, is called the Laniakea supercluster. Laniakea is a Hawaiian name that means immeasurable heaven, and the Great Attractor sits right at its center. You see, this discovery does so much more than just solve a single puzzle. It fundamentally reshapes our understanding of our place in the universe and the grand structure of the cosmos itself.
The big takeaway here is that our galaxy isn't some lonely island floating in an empty void. Not even close. We are deeply, fundamentally connected to our cosmic neighbors. We're all passengers on this vast cosmic river, flowing together towards an unseen force that's shaping our collective destiny.
So, what does it all mean? It means the universe isn't a quiet, still life painting. It's a dynamic, living, interconnected web of gravity. Everything is in motion. Everything is pulling on everything else, and it all forms these incredible structures of flow and convergence that span billions of light years.
And that leaves us with one final, truly awe-inspiring question to ponder. We now know we're all passengers on this incredible cosmic river flowing through the universe. The mystery of the Great Attractor has shown us which way the river flows. But the biggest question of all remains: what's waiting for us at the end?